Welcome to Crescent Long Island Smart Talk, where we discuss new technology that reduces our real estate costs. Today, we have with us John Culbertson and Lars Beshaw from IPLAN Access to talk with us about using smart batteries to reduce the cost of our electric bills. Welcome, John and Lars. Gentlemen, can you briefly describe your background and what IPLAN Access does?
Sure, I'll take that one. IPLAN Access is an infrastructure planning corporation that was put together basically for the commercial and industrial space. My background had been building fiber optic networks on Long Island, first to introduce broadband for both LightPath, Cablevision LightPath, and my own company, Open Access. First thing it did was make the building smarter. It actually reduced the cost to the tenants in there for broadband. We brought the cost of broadband really way down together.
My background's in energy. I've worked with a number of organizations that engage in energy curtailment measures, ECMs. I worked predominantly in New York City and still do with a lot of real estate investment trust organizations in the city, and working also with Con Edison and Lockheed Martin, which has been hired by Con Edison to essentially manage the process of energy curtailment measures, the measures and verifications, to make sure things are done right.
Right.
So right now, what we're looking at is most of these buildings out there have very expensive electric bills.
Right.
And these bills are going up as opposed to the power portion of the bill. It's called the peak rates are in the process of going up. Even though clients are lowering their usage and reducing their usage, they're seeing their bills go up. Even though clients are lowering their usage and reducing their usage, they're seeing their bills go up.
That we're talking about this possible solution of storage batteries that could significantly reduce the electric bill. Right? I'm astounded that companies could reduce their usage and still have increasing costs. Can you guys, Lars, can you explain to
There's a
how
couple of
batteries are can be useful here?
There's a couple of different components to your electrical bill. There's an actual consumption charge, but there's also another charge called a demand charge, and that's based on what you're going to demand from that utility, what type of power you potentially have. Demand charges are almost equatable with infrastructure.
Right.
So for example, when chillers come on during the summertime, you'll have a demand for it at that point, but no demand in the wintertime. But you still need that infrastructure to be able to support those devices. That's something that John and I work on with regards to batteries, is that we look at those demand charges, and then we essentially design a system for battery storage to be able to shave the peak off of those demands.
So it's going up. It's gone up 30% across the country in about 3 years. And we're going up higher because here in New York, the infrastructure is 50 years old. We were showing those when we did the meeting. And actually on Long Island, some of it's 60 years old.
You have to do both.
So let's just go to the batteries for a moment. You know, I've been aware of batteries for a long time, since I walked into what they call the UPS room, and I saw, you know, I don't know how many thousands of pounds of what looked like car batteries, and
Yeah, that's exactly what
powering a data center. And I said, wow, you know, first of all, the weight of those things were incredible, and every time we went out looking for a data center, we needed to make sure that the floor load could handle the batteries. I mean, that was the only thing that we needed to worry about the weight concerns. And then, of course, fuel cells. I mean, the idea of powering facilities with fuel cells. Are these storage batteries we're talking about different than the car batteries?
These batteries that we're utilizing now are lithium ion. That's the ones that Lars and I right now are honing in. And from all the authorities that we've seen, they are 5 years, 7 years ahead of the other different types of technologies that are out there. And one of the things it is, it's very dense. So we always like to paint the picture. For 1 megawatt of data, of bandwidth, of power, the footprint for the whole plant is one parking spot and 1,350 pounds.
There's a great life cycle, a story around lithium ion as well too, as far as the environmental friendliness of it. So we're very excited about it. People out in California, commercial office properties have been on smart meters. For example, they have a better understanding of what their energy usage is. And that has been something that's been mandated for, well over a decade now, maybe 15 years. And
In California.
In California.
Yes.
So here in New York City, New York State in general, we're just kind of catching up with regards to Con Edison just 3 years ago, instituted the mandate that all properties over X number of square feet had smart meters. And that's really everybody. So everybody now has a smart meter, and they're also instituting it out here along the 110 corridor.
I just came from a class just now. I went to that class. We just came from the PSEG Energy Show. And I went in for the smart meter class. And they talked about, someone asked them about when it's going to reach the residential homes in 3 years. It's going to take them 3 years. Now, and they're going to first start off this year. Part of Utility Web 2.0 it's called. I believe they're going to go up to 2,500 commercial accounts. The largest
Starting with, I'm sure, the largest of the office building.
They will. That's what they should do.
And then they'll put the smart meter in, right? It'll allow you to understand their demand usage.
Right.
And then we'll be able to figure out how to shape that demand usage and reduce the cost.
And do other things too with it. I mean, you can get to see, it's like an MRI of the building. As they institute other energy management solutions, they can see back into the results, looking at these, what happened and where it happened and when it happened on a daily basis, should they want to.
In some larger applications, there are other technologies that are used for demand shaving. Believe it or not, there are gravity feed systems, for example, where they pump water to a tank on the top of a cliff during the nighttime, and during the daytime they let a valve loose, turns a flywheel and generates electricity.
Niagara Falls.
Exactly, in miniature. They do that a lot out in California. There are organizations in New York City right now that essentially make ice during the nighttime, and it's more like a snow cone slush. With pipes that are going through it, and what they do is they pump water through it during the daytime when they need chill water for their HVAC systems. So what they're doing here, what both those technologies are doing, are essentially pulling equipment off the grid, pulling equipment that would spike up those demand charges, and using some other type of technology to store energy, whether it be making ice, whether using gravity as potential energy, and then therefore kinetic energy. And this is what they do.
Sounds to me like storing energy is the key.
Storing energy is definitely the key. And when you think about costs, batteries are without a doubt the best solution. Right now, the Department of Energy is working with Argonne National Laboratories in the JCESR program, for example, which is all about battery storage. And they're looking at all different types of technology for battery storage. And part of their mandate is what's called technology transfer, and that is moving the technology out of the national laboratories and academia into the private sector to make it available for people to use and to, in fact, reduce energy bills.